classification is energy and power signals. Before defining what is energy signal or what is power signal, first of all we must know the formulas of energy and power. First, take continuous case. What is energy formula? Energy equal to integral minus infinity to infinite x square of t dt. That is the total energy for a continuous signal x of t. Then what is the power? Power P is equal to limit t tends to infinite 1 by t integral minus t by 2 to t by 2 x square of t dt. For discrete case, energy is equal to sigma n is from minus infinity to infinite x square of n, and power P equal to limit n tends to infinite 1 by 2n sigma n is from minus n to n x square of n. These are the formulas for energy and power. Now we will see what is an energy signal and what is a power signal. Energy signal. A signal is referred to as energy signal if and only if the total energy of the signal satisfies the condition 0 less than E less than infinite. A signal is said to be energy signal if its total energy satisfies the condition 0 less than E less than infinite. Okay, so this type of signal is called energy signal. Another important point is energy signal has zero average power. Please remember it. Same way, what is power signal? Power signal. A signal is referred to as power signal if and only if the average power signal satisfies the condition 0 less than P less than infinite. That signal is called power signal. They'll give one signal, then find out the power. If the power is finite value, that is between 0 and infinite. Here also if the energy is finite between 0 and infinite, the given signal is said to be energy signal. For the energy signal, the power is 0. Here find the power. If the power is finite, then the signal is said to be power signal. And power signal has infinite energy. Power signal has infinite energy. Okay, these are the definitions of energy signal and power signal. Another important note point here is periodic signals, periodic and random. These two comes under power signals. Similarly, aperiodic and deterministic comes under energy signals. Means for the periodic signals we can find the power, and for the aperiodic signals we can find the energy. Now we will do some problems on energy and power signals. Determine whether the given signals are power or energy signals. That is the problem statement. Determine whether the given signals are power or energy. Under this, take the first problem as x of t equal to e power minus 2t u of t. Okay, then you have to find whether this signal is energy signal or power signal. For that, you need to find first the energy using this formula. Integral minus infinity to infinite x of t, or you can say mod x of t whole square dt. Here also you can, instead of this, you can take x of t mod square actually. If you find, yes, it is integral minus infinity to infinite mod x of t whole square dt. But see here, x of t is e power minus 2t u of t. And you know u of t is like this. It exists for greater than 0. It tends to infinite. It exists up to infinite. But less than 0, it has no value. So accordingly, you have to modify the limits. It is integral 0 to infinite, because less than 0, we don't have signal. So it is simply e power minus 2t whole square dt. Then what is e now? E is integral 0 to infinite e power minus 4t dt, because it is exponential. So it is e power minus 4t by minus 4 between the limit 0 to infinite. What are you going to get? You are going to get 1 by 4. So your e is 1 by 4. Similarly, find the power using the formula limit t tends to infinite 1 by t integral minus t by 2 to t by 2 mod x of t whole square dt. Here also you can take, instead of this, you can take mod x of t whole square dt. Same, limit t tends to infinite 1 by t integral minus t by 2 to t by 2. In the negative portion, your u of t won't exist, so you have to take like integral 0 to t by 2 mod x of t whole square is e power minus 4t dt. Limit t tends to infinite 1 by t e power minus 4t by minus 4 between the limits 0 to t by 2. So the answer is limit t tends to infinite 1 by t. If you substitute t by 2 here, it will be e power minus 2t minus 1 by 4. So now if we substitute t tends to infinite, it will be 0. Remember, you have to substitute t tends to infinite in the last step. Up to that you have to do modifications, you have to do simplifications. At last you have to substitute t tends to infinite. Then you can find the power. Because here in this problem till the end you have t. But in some problems it may get cancelled. That is the reason substitute t tends to infinite only at the end. So if you see this problem, energy is finite and power is 0. So energy is finite, power is 0, hence the given signal is said to be energy signal. I think it is clear. The given signal is said to be energy signal. Now take other problem. Find whether the given signal is energy signal or power signal. Same. Find out your E. Integral minus infinity to infinite x of t whole square dt. So integral minus infinity to infinite a square cos square t dt. So it is a square integral minus infinity to infinite, right, 1 plus cos 2 theta by 2, like 1 plus cos 2t by 2 dt. Just do the integration. a square, take otherwise this by 2 also common. Integral minus infinity to infinite 1 dt. So t between the limits minus infinity to infinite plus integral cos 2t sin 2t by 2 between the limits minus infinity to infinite. Okay, so now if you substitute the limits, obviously you can see this, you'll get when you substitute in the first term, infinite minus of minus infinite, it will be infinite, infinite plus anything is infinite. So the energy is infinite. Same way, if you find the power, limit t tends to infinite, 1 by t integral minus t by 2 to t by 2 mod x of t whole square dt. It is limit t tends to infinite 1 by t same if you substitute, I'll get a square by 2 into t plus a square by 4 2 sin t. Just you substitute and do the and just substitute your minus t by 2 t by 2. Here you have to substitute minus t by 2 to t by 2 because the given signal is not multiplied with u of t. If it gets multiplied with u of t, then only you have to consider that positive portion and you have to remove the negative less than 0 portion. But here it is not multiplied with u of t, so you have to consider the total range. Here it is minus infinity to infinite and here it is minus t by 2 to t by 2. Okay, then take 1 by t into the brackets, t gets cancelled, here 1 by t. Then if you substitute t tends to infinite for this 1 by 2 term, it will be 0 and you will be with the a square by 2. So it is finite. So energy is infinite, so the power is finite, so the given signal is said to be power signal. I think you clear with these two problems. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.